And one comment I wanted to say is
Yeah.
that with cannabis, we're finding that a lot of people reporting they can't give it enough light. There are a lot of the more modern cultivars, plant types, they are being bred to survive under really high light conditions. So the average requested light level best practice in a grow room is going up over time generally. So your customers are going to be, the efficiency will keep increasing, but the amount of light will keep increasing too. So the net energy is going to probably keep going up.
Yeah, until we get to that energy efficiency stage, right, where we're still trying to max out production, because cannabis can take so much light and still not see that saturating effect, those diminishing returns, depending on the cultivar, of course, the strain. They want to give it more light so they get more yield, right, at this point in time. That's very different in Europe, right, where, for example, they're really looking to optimize energy efficiency and COMAG, not necessarily looking to maximize production.
Yeah, no, if all we have to do is look over to lettuce production, and they have a totally different scheme based on this, where they Leora, as you're saying, like they purposely don't put as much light as the plant could take because they've made an economic cost benefit and saying a lower light but slower production is okay for this market. Cannabis will get there for sure. It's just not there. It's just not there yet.
So I just want to make sure that just on the slide really quickly, and I'm thankful to Fluence for offering these very nice graphics that we've been using at these webinars. So PPFD is like your luminance meter. It's that instantaneous measurement that you make at any given time. You're going to get a PPFD value from your electric lighting, right? Your LED lighting or your HID lighting. You could get a PPFD value from sunlight if you're growing in a greenhouse or in a grow house. And obviously those add up. And then if you take that meter, that PPFD meter, the sensor is a little bit different because of how we're measuring light for plants, and you attach a logger to it, and you simply log all of that light when your light is available, whether it is from daylight, which you can see here obviously increases in the middle of the day and then reduces at night, or from electric lighting, which may be static, may or may not be dimmed. You basically sum up all that light, and that's your daily light integral or your DLI. So you're just logging that light over a 24-hour period.